Hey you guys, this is Miss All Day. We are going to start our new lesson today. So we're still in the transformation chapter 9, and this is day 3. We're doing 9-3 rotations today. So just to refresh your memory on what we've done so far. On the first day, we did translations. Okay, so if I was going to translate, I would say I'm going to translate 4 units to the right. That means I'm going to change my X value. And 2 units down. And then I'm going to tell you what I'm translating. We'll say triangle ABC. And when I translate it, yes, I'm going to end up with triangle A prime, B prime, C prime. All right, so that was a translation. All right, yesterday we did a reflection. And we used the capital R for a reflection. And then we said which line we were going to reflect it over. So I'm going to say X equals 1 is what we're going to reflect. And let's say we were going to reflect triangle ABC, and it was going to end up being triangle A prime, B prime, C prime. So you see that we did a translation and a reflection. Now both of those were considered rigid motions. All right, let's look at today's lesson for rotations. For rotations, just so you know, we're going to use a lowercase r because capital T was a translation and capital R was a reflection. So now we're going to use a lowercase r, and that's going to be rotation. All right, so I'm going to underline kind of as I talk. If you want to follow along in your book, we are on page 561. All right, so the first point here is that rotation preserves distance, angle measures, and orientation. All right, so I want to key in on distance and angle measures. That means that it's a rigid motion because remember, translations and reflections also preserve distance and angle measures. All right, now we're going to look at this information in this table, box, whatever you want to call it. But it's a lot of information, so we're going to take it a little bit slow. All right, a rotation of X degrees. Okay, that means however many degrees you're going to rotate it. That's going to end up being a number. But for right now, since we don't know what number we're going to use, we're just going to say we're going to rotate it X degrees. So it could be 90, it could be 270, it could be 360, it could be 180, it could be 30, 40, it could be lots of things. All right, about a point. That means around the point. Okay, so we're going to do a rotation of this triangle here, triangle UVW, and we're going to do it about point Q. All right, so let me tell you what that means. That means when I rotate around this point, that the distance between Q, the point I'm rotating it around, and the figure will not change. All right, so I'm going to do this in blue just to show you. So if I have QV, and that's the distance between Q and my V, and I rotate, let's say this angle of rotation here, let's say it's about 45 degrees. We're not really sure what it is, but let's say it's 45 degrees. If I rotate V 45 degrees and it becomes V prime, the distance, and this right here is the same thing that I'm fixing to say, the distance from Q to V is going to be the same distance from Q prime to V prime. And it just so happens because we're rotating it about point Q that Q prime and Q are actually the same point. Okay, because that doesn't change. All right, let me show you something else. If I'm rotating point, I'll do purple this time, W. Okay, and the distance from Q to W is this far. And I rotate it about that point, and I do 45 degrees. The distance from Q prime to W prime is going to be the same distance as it is from Q to W. All right, and we can do that for each point. Let's pretend like we're getting ready to rotate U. The distance from Q to U is going to be the same distance from Q to U prime. Okay, so the distance is preserved. All right, and all the angles, they didn't change when I move it. They all stayed the same. All right, so let's go back to this information over here. A rotation of X degrees about point Q is called the center of rotation. Okay, and I've already kind of talked about the two properties, that the image of Q is itself. So when I say I'm going to rotate about this point and I rotate it, this Q and this Q prime are really the same point. Okay, because you're rotating it about the same point. All right, for any other point, we're gonna use V as an example. Okay, what this is saying here, if I have V here, and I know that QV is, let's say, 3 centimeters long, then Q prime V prime is going to be 3 centimeters long. Okay, and you could also call that QV prime, because really you don't have to put the prime there because that point really didn't change. So that's showing that it preserves distance. And this point right here is saying that the measure of angle VQ V prime, so I'm going to do that in green, this angle right here, that's going to be your degree of rotation. Okay, that's going to be maybe 45 degrees for this one. We're just kind of guessing. All right, the number of degrees a figure rotates is called the angle of rotation. So this is the angle of rotation. All right, a rotation about a point is a rigid motion. We already said that. So now I'm going to show you how you would write this out. And I'm just going to kind of rewrite this part right here. Okay, if you're going to rotate X number of degrees about a point, and you're rotating a figure like triangle UVW, you're going to write it like this. I'm just going to walk you through it. I'm going to rotate however many degrees I decide. That's going to be a number. I'm going to rotate it about point Q. What am I rotating? I'm rotating triangle UVW. And when I get finished, what's my end result? Triangle U prime, V prime, W prime. So that's what it's going to kind of look like if you're looking at it like a rule. Okay. All right, let's go to this part right here. I'm going to just pause just for a minute. Just checking my page number so I could guide you. This statement right up here is on the bottom of page 561, okay? Unless otherwise stated, rotations in the examples in your notes and in the textbook and any workbook pages are counterclockwise. This is very important. Counterclockwise. So we're not going around this way. Okay, that's no. We're going backwards this way. Okay. All right, so counterclockwise. All right. Let's go ahead and look at problem 1. This is located on page 562. So this is page 562. This is our first problem. And we're going to draw a rotation image. Now, this is going to be quite interesting, okay? Because I cannot put a ruler on my screen and I cannot put a protractor on my screen. But if you want to pause right now and get your ruler and protractor, this is going to greatly help you do this. So go ahead and pause me if you need to and get that. All right, so what we're going to do, let's go ahead and read what we're doing first right here. We're going to rotate 100 degrees about point C, and we are rotating triangle LOB. And when we get finished, we should have triangle L prime, O prime, B prime. All right, so let's look at this picture. And what's hard too is if you don't have these notes like sitting in front of you writing on it, you're going to want to take this right here and maybe trace over it on a piece of computer paper. That way, you know you're doing the same problem we're doing. And your OBL, your triangle OBL looks like that and has the same dimensions, and your C is however far from O. So you might want to just trace that if you're not like writing on the notes itself. All right, so our first step, I'm just going to kind of write the steps as we go. The book has them too, so if you want to look at theirs, you can. But the first step is I'm going to draw segment CO. All right, so you would use a ruler, but I'm going to go from C to O and try to draw a straight line. All right, so that's your first one. Now, within this first step, you're also going to use a protractor to draw a 100-degree angle. Now you're like, okay, what in the world do you mean? Okay, I'm going to do this in green. You're going to set that little circle of your protractor right here. And you're going to line up this red line with the line on your protractor. So literally, if you're doing it on this paper, it's upside down and you might want to turn it. I can't really turn my paper. So if I was lining my protractor up, it's going to look something kind of like this. Okay. Now I'm going to go 100 degrees. It's probably about right here. Okay, so I'm going to make a little mark, and then I'm going to move my protractor because I don't need it anymore. And I'm going to draw from that to that point. I'm just going to draw it out. I don't know how long I need it, so I'm just going to draw it out. All right, this angle right here is now 100 degrees. I am rotating point 0 about point C. Okay, now I'm going to erase this little dot. Okay, because I'm just looking at the angle. So erase that dot. Okay, now our second step. We're going to construct CO prime segment, and it's going to equal segment CO. All right, so I'm going to do this in blue so you kind of know where I'm at. You see this segment right here, how long it is? I've got to duplicate that. So you pick up your protractor. You pick up your compass, not your protractor. Remember the thing that has the little point on it? Okay. You're going to put the point here, and you're going to spread it out till you get to O and make a little mark right there. You're still on that point, so take that mark, and then I want you to come over here and swing it over there. So what we just did using a construction is we created a congruent segment. So this right here now is O prime. Now you have to do that with every single point. Okay, so what does that mean? That means for your third step, you're going to have to draw a line. You're going to have to do the angle, and you're going to have to construct a point. So what do you mean? I'm going to have to do all that again? Yes, but this is what we're locating. We're going to go locate B prime, and we're going to go locate L prime. I'm going to walk you through how to do that, okay? I'm just going to use purple this time. All right, now find L prime. We'll do it next. Draw a line from C to L. Now pick up your protractor, put it right here again, okay? You're going to do a 100-degree angle. So I'm thinking that's going to come right about here. Okay, so go ahead and move your protractor. Okay, so this angle right here is about 100 degrees. All right, so the first thing I did is I drew CL. Okay, I used my protractor to draw a 100-degree angle. Now I'm going to have to construct CL prime, and it has to be equal to CL. So from C to L, you put your compass on. Let me erase that little arrow because it looks like an L. I don't want you to get confused. This is the L I'm talking about down here. You put your compass on C, you spread it out, and you measure how long that is. And then you just swing your compass over to the other purple line, and you measure about how long that is, about right there. And you label it L prime. Okay, I'm going to erase that mark, and I'm going to erase this mark down here. Erase this arrow. I'm going to erase all these steps here, so because we're going to go back now, and we're going to go do B prime. All right, so let's see. I'll do B prime in brown. So I'm going to draw from C to B. All right, C to B. All right, got that done. I'm going to use a protractor and I'm going to draw a 100-degree angle. So basically, there's my protractor basically, and I'm going to draw a 100-degree angle, which means it's probably going to be about right here. I'm going to move my protractor and you can kind of see. So you can see this right here. Oh no, it just undid my lines. Let me fix that, you guys. All right, sorry, I had to fix my lines real quick. I erased them, and they're not perfect, but they'll do. All right, so now this right here is a 100-degree angle. So we're going to construct C, B prime, and it's going to have to be equal to the distance between C and B. All right, so you pick up your protractor. Sorry, I keep saying protractor, I mean compass. You're going to put it on point C. You're going to spread it out and see how long or what the distance is from C to B. Then you're going to swing it over and you're going to make that mark. Okay, I'm going to erase these stray marks real quick. I'm going to put this point here and then I'm going to erase that stray mark. And I'm going to name that B prime. So now I have located B prime and L prime. So now you're going to basically draw the triangle. So we're going to put fourth step is to draw triangle L prime, O prime, B prime. Okay, so that's a lot and that's pretty involved. So we're not going to do that again for the got it problem. I'll show you what we're going to do for the got it problem in a minute. But I want to show you what mine looked like when I did it using a real protractor, a real compass. Basically the same picture that you just see, but this is precise. These are definitely 100-degree angles that were created. So we were able to rotate 100 degrees about point C, triangle LOB, and we ended up with triangle L prime, O prime, B prime. All right, so let's move down here to example number 2. And I don't know if you're doing your got it problems on separate paper, if you're doing it on your notes. It doesn't matter to me. But this is the got it problem. And this is got it problem number 1. We're only going to do 2 got it problems. All right, so in your textbook it says, copy the triangle LOB from problem 1. We're not going to do that. So I'm just going to erase this and show you that they're talking about the same triangle right here. Sorry. They're talking about the same triangle right here. Okay, so this is the same triangle we're talking about for the got it problem 1. We're not going to copy it. We're just going to look at it. There it is right there. All right. What is the image of triangle LOB for a 50-degree angle of rotation? About point B. Now, do you notice we're not doing it about C? We're doing it about point B. So when we're doing it about a point, and that point is located on the triangle or whatever the figure is that we're fixing to rotate, then that point B is also going to end up being B prime. Okay. So what I decided to do was I copied the examples from the online Pearson textbook for you to pick which one would be right. Which one of these 2 pictures would be the image of LOB for a 50-degree angle of rotation about B? So think about that for a minute. And if you're like, well, you just got finished saying, Miss Allday, that if I'm going to rotate about point B, that B is actually going to become B prime, then this has to be the picture. Okay, so I want you to look at, let me erase the green, and let's look at, this is the pre-image right here. Okay, and if I'm going to rotate about point B, I want you to think about this, that the distance from O to B is going to be the same distance from B to O prime. And don't those look like the same distance? So that looks good. All right, let's try L from L to B is going to be the same distance from L prime to B or B prime. Yep, those looks like distance was preserved. All right. And then that's it, because B is B prime. Now, if you look over here, you're right. This is the answer. So your answer is A. But if you look over here and you're saying, okay, I want to rotate about B. If I'm rotating about B, B prime cannot be off B. B prime and B have to become as one. If you are rotating about a point that is on the figure, then that point will be the new B prime. All right, so that was your got it problem. All right, we are still on page 562. I put this, though, on the first page of the notes, though, okay, just to kind of put all the information on one page. All right, so let's look at this. This is going to talk about when you're drawing rotations in a coordinate plane. So let's focus in on this. When a figure is rotated 90 degrees, 180 degrees, or 270 degrees about the origin, okay, that means they're going to stay the same distance from the origin. In a coordinate plane, you're going to use the following rules. So let's start with this first rule. If I'm going to take point G and I'm going to rotate it about the origin, okay, that means the distance from the origin to G, once I rotate it 90 degrees, and you can tell that's a 90-degree angle right there, okay, it's going to end up over here in quadrant 2. This is quadrant 1 and this is quadrant 2. Okay, that's what's going to happen for this picture. Now, every time you rotate using 90 degrees, it's not always going to be sitting in quadrant 1, and it's not. So it can't always be in quadrant 2. But you will always use the same rule right here. If I'm rotating 90 degrees about the origin, and I'm rotating whatever this point is, you are going to switch your X and Y. So it's going to be a Y and an X. And then your first coordinate is going to become negative. So watch how this worked. Take these two numbers right now and switch them. 3, 2. Now make the first number, which is now your X coordinate, a negative. Isn't that the same number right there? Isn't that negative 3, 2? So this is a rule that we're going to use right here. We're going to want to remember this, okay? You're going to want to memorize this. If I'm going to rotate 90 degrees, that's what I'm going to do. All right, let's see what's going to happen if I rotate 180. All right, if I took G, which is 2, 3, and I rotated it about the origin 180 degrees, then it's going to end up down here in quadrant 3. Now, remember, it's not always going to start in quadrant 1 and end in quadrant 3. If it starts in quadrant 2, where's it going to end up at? Right, quadrant 4. So this is the rule. If I rotate 180 degrees about the origin and I'm rotating my point XY, so look right here at this point, look what happens to your X and your Y. Your X and your Y just become opposites of whatever they are. So in this case, you write the 2 and the 3 and you put negatives in front. And doesn't that match what we got? So you're going to want to memorize these rules. I would put them on just a little sheet of paper right there. You're going to do the opposite of what they are. This is if you are rotating 180 degrees. All right, let's go down to this one, and this is 270. So that's like going like this. This is 90, 180, 270. Okay, kind of like Pac-Man. All right, so I am right here at G. I am rotating about the origin. So I'm going to do my distance here. Remember, that distance has to stay the same. When I rotate all the way around to do 270, I end up right here. That's my G prime. All right, so let's see what really happens. Let's look at the rule. If I rotate 270 degrees about the origin and I'm rotating XY, look what you're going to do to XY. You're going to flip them again, right? All right, so let's take the 2, 3 and let's flip it. 3, 2. But this time, it's the second coordinate that becomes negative. It's not the first one. It's the second one. So this is going to be negative. Now look, doesn't that match? 3, -2. All right, so whenever you have a 270-degree rotation, you're going to flip your X and Y, and you're going to let your second coordinate end up being the opposite of whatever it was. Because it's not always going to be positive turn into a negative. It might be a negative turn into a positive. Now this is the easiest one, and this one you should know. If you start in one place and you do a full 360, you're back in the same place. So that one's not really even one to learn. But those three are the three you need to learn. All right. Let's go now to page 563. And it's going to be right here. This is going to be problem 2. So this is page 563. And the first thing we're going to do is we're going to have to go draw some points. So we want to create PQRS, and these are the vertices. So let's go put those in there. All right, so let's do P is 1, 1. All right, and let's label it P. All right, Q is 3, 3. We're going to label it Q. R is 4, 1. I'm going to label that R. And S is 3, 0. And we're going to label that S. All right, so go ahead and connect those. If you're looking in your book, they already have this figure sitting right there. So if you're not doing this part, that's okay, because the book already has that part. All right, so PQRS has the following vertices. P is 1, 1, Q is 3, 3, R is 4, 1, and S is 3, 0. What is the graph? Change colors here for a minute. Excuse me. What is the graph if I rotate 90 degrees about the origin and I'm rotating PQRS? So I'm rotating the whole thing, but you go point by point by point. You do not rotate the whole thing at the same time. So what we're going to do is we're just going to write down all the points for rotating. So P is 1, 1, Q is 3, 3, R is 4, 1, and S is 3, 0. Now, why did I write those again? Because I'm showing you piece by piece how to do it. If I'm going to find P prime, then I'm going to have to rotate 90 degrees about the origin, this point. This is the point I'm rotating. All right, now go back to your chart and go find what 90 degrees is. I want you to write this down. -YX. All right, so I'm going to go back to that. And we're going to write this down kind of as our guide. -YX. So I'm going to have to switch every single one of my X and Y. So 1, 1, 3, 3, 1, 4, 0, 3. Now, after I switch them, my first one has to be the opposite. So opposite, opposite, opposite. And you can't do a -0. There's no such thing as a -0. All right, now you might want to do this with another color. It doesn't really matter. Go plot those points. I'm going to do it in blue. So I'm going to plot my P prime is -1, 1, and then I'm going to name it P prime. See if I can make this a little bit bigger for you. My Q prime is -3, 3, and that's my Q prime. My R prime is -1, 4, and that's my R prime. And then my S prime is 0, 3, and that's my S prime. Now connect the dots. You just rotated that 90 degrees. The angle measures didn't change. The distance didn't change. All right. All right, great. Now, the next one is the got it problem right here. So if you want to write got it here, this is the got it problem. This is got it problem number 2. It's the last problem we're doing. We're not going to do problem 3. So if you're doing this on your own and you're not listening to me right now, then you probably did problem 3. Have fun. We're not. We're stopping it. Got it problem number 2. So we're going to do got it problem number 2. Now, the first thing we're going to have to do, though, because for got it problem number 2, they already have the picture in the book for us. We've got to go draw that picture real quick. All right, so we're going to do F is negative 3, 2. And that is F. And G is negative 3, negative 1. And H is negative 1, negative 1. And I is 0, 1. All right, connect those dots. Kind of squiggly. Yours probably look great. All right, and we don't have to say whether that's a trapezoid or a square, or rectangle, or quadrilateral. We just say this is FGHI because we're not really sure what it is. All right, next, after we graph those points, we're going to graph the rotation 270 degrees about the origin FGHI. All right, so go back to your chart and find the 270 degree one. All right, write that down. Put y negative x. Because until you get used to it, that's just the easiest way for me to show you how to do it. So I'm going to do it in different color. It'll be red. Y and negative x. I don't know where that little dot came from. That's weird, right? It was probably supposed to be right here, and it didn't show up there. It's supposed to be a degree. All right. So now we're just going to go write all of our original points. So for F, negative 3, 2. G, negative 3, negative 1. H, negative 1, negative 1. I, 0 and 1. So I'm just going to go through this and read it again. To find F prime, I have to rotate 90 degrees about the origin, this point. Okay? But we're not going to do all that hard manipulating rotation. We're going to use the rule because that's the easiest way to do it. All right, so let's do purple. So we're going to take, oops, put this back. And we're going to switch them first. You see how they're switched? Okay, so we're going to do 2, negative 3. And we're going to do negative 1, negative 3. And we're going to do negative 1, negative 1. And we're going to do 1, 0. Okay, so I switched them. Now the next thing I'm going to do, I'm going to show you this in black, is I'm going to do the opposite. Whatever is sitting in the second coordinate, I'm going to change its sign to the opposite of what it is. So for this one right here, that's going to become a positive because negative, negative makes that a positive. Opposite of negative 3 is positive 3. All right, with this one too, this is going to become a positive. Okay, this one's going to become a positive. And then I don't have to do anything to the 0. All right, those are my points I'm going to go plot now. So for F prime, I'm plotting 2, 3. 2, 3. For G prime, I'm doing negative 1, 3. For H prime, I'm doing negative 1, 1. And for I prime, excuse me, I'm doing 1, 0. All right, connect your dots. What have you done? You have done this. You have rotated 270 degrees about the origin. And what did you rotate? You rotated FGHI. And what did you get? You got F prime, G prime, H prime, I prime. That's just to show you that's kind of what it is that you did. And that's the rule. All right. We're at the end of this lesson. So I'm going to jump over here to today, which is Thursday, April the 16th. And you don't have to do that third got it problem. You have 2 got it problems you should have done. And then here are the other ones that you should have done. 1 through 4, 9, 15, and 19. And those are the 2 things I need you to upload. And if you're using my notes, of course, and you wrote on them, you're uploading that as well. Because you don't have to go rewrite the got it problems again. All right, you guys, I miss y'all so much. I hope you're being being safe, and I hope this is working out for you guys. I know it's a lot juggling all your classes online. So just reach out to me whenever you need me. All right?